Okay, so we're going to talk about file handling. Don't know why that sometimes has an issue. There we go. So normally I'd put things in a package. Right now it's just a demo, so I'm not going to bother. So, like I said in the notes, you can use the file class or the path class. They're kind of, for what I'm doing right now, they'd basically be the same thing. If you actually want to interact with a file system, use the path class. If you're just trying to grab a file, using the file class is a little more convenient. So dot is special. It tells you what the current working directory is. Basically, that's where you're running the program from. So what this is going to do, I'm just going to make a brand new file. I'm going to pass it dot, and I'm going to print out the file dot get absolute path. That's just going to tell us exactly where the program's running from. Quite often, when you're running in an IDE, you want to find out, you go to open a file and it's not there. It's not where you think it'll be. So this will help you figure out where exactly it's running from. So in this case, it's running in users, Darcy, idea projects, input output, and that's the directory. So any files I open are going to open by default from there. I can change that if I want. So we can see that there's this source directory, there's the out directory. So let's just make a, so I've got it. Let's just make a file. Little file with hello world in it. And let's recompile and just see. So right now you see the output, and I just want to see if it copies the test.txt. Again, depending on your IDE, this may or may not happen. And it did get copied to the output. So based on this, I have two choices. I could go, if I wanted to open the test file, I could go and open up something like this. I could say src / test.txt, and I could run that, and we'll see if it works. Right? And if I could actually add another system output line. Sorry if you hear my son in the background, he's talking to friends. File.exists, exists, so we'll see if it exists or not. And it does exist. But let's say what often happens with students or non-students is you just want to do this. So I want to open up the test. It's in the same directory, and you'll see it doesn't exist. So what we can do is we go to our file project structure. Was that it? No, sorry. It's go to our edit configuration. And in here, one of the things we can say is where our working directory is. So we could select to put that into source. Or we could select to put that into, I don't remember the exact directory, the output directory. Right? Your choice as to what you want to do. So let's go ahead and change that to source because it's less to type. I am that lazy. And now we see it comes out as true. So now we figured out where can we find files from. So that's cool. Useful to have. I'll just leave that commented in. You can comment it out later. Normally, if you're just typing down the command line, like this, Java main test.txt, it would be, first off, I can't find the class and all that. Don't worry about that because I haven't compiled it in a way that it would expect to find it. But this is how you would normally run things, and it would be in whatever directory you're currently in if you're on the command line. So let's go ahead and read from that file. Now that is a text file, right? It's got the word hello world. So let's go ahead and make a, actually let's do it the way you should do it. reader, not writer. Now, it's unhappy because we haven't dealt with the file not found exception. So what this try catch, or what this weird try block does, it's the try with resources. It's going to open up the file, and when we're done with the file, it's going to close the file. Used to be that you'd have to add a finally block. You wouldn't have anything inside the try at all. You'd add a finally block and deal with the close that way. This is a little more convenient. So we still have to do the catch though. And this is what I was saying. It's perfectly expected that when you go to deal with opening up a file, that the file doesn't actually exist. Also, when you close a file, it can have an I/O exception. So what we want to do is reader.read, and we can read a character at a time. It returns an int, not a character. That's because characters are unsigned. They start at 0 and go up to about 32,000, I think. If you read past the end of a file, it's going to return -1, kind of thing. So I think that's the logic there. So we'd have to actually go look at what read. Didn't actually say. But anyways, there's some cases where it returns a negative value, and you can't do that with a char, so you have to return an int. A very common thing to do. The reading this kind of API is fairly low level. We're going to take that int and treat it as a character, otherwise it'll print it out as an int. So bare minimum I can do is print stack trace. Now you'll notice it's complaining because we've got two things that are exactly the same. So I'm going to do that other, I'm going to say new, but it's not new, it's been there for a long time. Okay, so let me undo all the stuff I just did. So the initial thing it's complaining about is that these two catch blocks are doing the exact same thing. And if they're doing the exact same thing, we can go ahead and combine them to be a singular one. Awesome. Unfortunately, the IDE isn't very smart, and it's not realizing that, wait a second, file not found exception is a subclass of IO exception, and you're not actually allowed to combine catches like this. Or I guess you're not allowed to because it's compile time error, but it makes no sense, because if you're catching IO exception, you're also catching file not found exception. So we will just get rid of the file not found exception. And we'll run this and see how it goes. So it got the H, right? And if I didn't make this final, H got the E. Woohoo. So let's see what happens if we just throw it in a for loop. We go forever. I hope something bad happens. Should blow up. I'm not worried about that. This is just I'm playing around to show you something. This is not very usable. And you'll notice it just keeps on reading. And reading and reading and reading. And I'm going to have to figure out how I actually stop it. How do I stop it? Oh, I hit stop up here. So I actually need to say int. So I'm going to use a different kind of loop. I'm going to use a do well. So I want to keep reading until c is not equal to -1, or c is greater than or equaled to 0. Right? So as long as c is greater than or equal to 0, it'll keep going. The problem is c is only visible inside of this here, right? When you declare something inside of a block, it's visible only within the block. The well is technically outside of the block. I don't know why they did it this way for do well. It seems odd, but okay. So we're gonna run this and see what happens. So now it prints out hello world, and then the new line stuff and all that. So you can't see the non-printable characters, but we're able to print out the whole thing. That's not great. I'd really like to read the word hello all at once. I can't do that because reader only supports a few methods, right? So read, right, with into a character buffer, blah, blah, blah. So I'm actually going to change this to, instead of be a reader, I'm going to change it to a buffered reader. And I can't take a file reader and assign it to a buffered reader. I could, before I just had reader here, and a file reader is a subclass of reader, so that worked. And this is an example. So one of the groups was asking, can I give you an example of when a wrapper gets used? And I couldn't just think of one on the spot. They're used all the time, but not it's not common to make your own. So that's where I was stumbling. But here's a perfect example. Buffered reader is a wrapper. It wraps another reader, right? So you're passing a file reader to the buffered reader. And every time you read from the buffered reader, it ultimately reads from the file reader. So that's a wrap. There's an example of a wrapper. So now, reader dot read line. Aha. So now it should print out hello world all on one line. Voila. But let's say in our test file, we actually have a number. Let's do the same kind of thing and just see what happens if we do the same kind of for loop that we did before. So the first time it should read hello world as a string, and then it should read world. Read 42 as a string. And it's printing out null a whole bunch of times. So that doesn't work out so well. So it's the same kind of thing, right? So do, we'll make the line equal to that. Well, line not equal to null. Now notice it prints out the null. It printed out hello and 42. So that means we usually do something like this. So that's quite common. The problem is, though, that I've actually read this in as a 42, read 42 in as a string, and I don't want to do that. So I actually want to do something even different. I want to make a scanner. Okay, so this is looking a little more like what I would expect to see. In this case, scanner is not a wrapper because it doesn't have this. It's not a kind of buffered reader. That's the other thing. The buffered reader is a wrapper because it is a reader, and we're passing it a reader. And all it's saying is when you read from me, I'm actually going to read from that. Scanner is not a reader, so it's a completely different thing. It's the class that happens to use a reader. So there's a difference there. So scanner's cool. Scanner. Actually, I can do that. We'll start off simple. So scanner has a next line method. And notice that it's actually intelligent, right? It's not giving me next line. That's because next line returns a string, and we're assigning it to a string. So scanner dot, in this case, it's going to be searching for things that are ints. Maybe not, because the string shouldn't be showing up there either. So sometimes it's smart, but I want to read it as an int. So there we go. I'm still getting the hello world, and I'm getting 42, but 42 this time read as an int. Problem. Let's call it x42 and run it. Exception. It's got an input mismatch exception. Now, I'm annoyed by this because I fully expect when I'm scanning something that I'm going to screw up. It's completely reasonable. So this should be a checked exception. It is not a checked exception. Not really thrilled that it didn't do that as a checked exception. Right. So that's okay. It is what it is. So what we're supposed to do is say if scanner dot has next. And I believe it'll just read it has next just by default as a string, but you notice I've got ints, big decimals, big integers, boolean, bytes, long, double float, line, right? So if it has next line. So that's telling you, does it have a line? That it's going to read it. And normally what we'd do is else, throw. Now I'm just going to throw a runtime exception. I'm being lazy. What I would do in my real code is say, okay, I want to throw this specific exception. Or do whatever else is appropriate. And there's also scanner dot has next int, right? And what I'll do in this case is instead of throwing it, I'll say else value is assigned -1. And we'll run it. And look, it didn't crash this time. We got -1. You're going to have to play with this to see exactly how you want to deal with it on a case-by-case basis. But that's the gist of it. So that's that one. I'm going to make another main. So that's reading from text files. This time I'm going to read from not a text file. I'm going to actually read from a byte file, so a binary file. But I don't have a binary file handy. So instead, I'm going to actually read from a byte array, because I can do that. Now, it gets a little wonky, because if I put in a 1 here, and a 2 and a 3, that's all fine. What happens if I put in 255? It doesn't work. Now the reason it doesn't work is because that's an int, not a byte. 127 should be fine. 128 will not be fine. A byte is 8 bits. That's 0 through 127. There's 128 unique values. It's binary. I can't show you with my hands. It'd be like this. So there's 8 values here. Right, 0 through 7. And this one on the left is the, or on the right is the 1s. This is the 2s. This is the 4s. This is the 8s. This is the 16s. Well, that's ugly. 16s. This is the 32nds. This is the 64s. And I think I've gone one too many. I'm having a bad day. I'll come back to that. My mind is failing me. Oh, I think no, it's just the. I think it's just the formatting that I'm trying to do here. No. Oh no, sorry. I know I am wrong. It's perfectly right. So it's not 0 through 128. It's negative 127 through 128. So I said one minor thing wrong. I set my whole day off wrong. So I should space this out evenly. So there. So we can have, if you added up all these numbers, you're going to get to 255. Right? 128. I don't know if you can see this. I'm just bringing up my 64, 32. Sorry, calculator kind of thing. 16, 8, 4, 2, and 1 is 255. Right, so add those all up, you get that. But it can't go to 255 because Java only has what's called signed numbers. That means they have a negative and a positive. So you have to take the 255 and cut it in half, essentially. So we should be able to do minus 128 works. Sorry, I said minus 127 before. Minus 128, but minus 129 won't work. So if we wanted to put in 255, it's actually kind of cool. If we put in 255, it's going to say you can't do that. I put that in as a byte with a cast, and now it does do that. But what it actually makes it do is go from 255. You'd think it would go to 256, but it can't. But what looks like 256 is actually negative 128. So it just wraps around. If that made no sense to you, don't worry too much. You don't really need to understand all that, but you've got it there. So I'm just putting in 3 bytes here. And now what I'm going to do is I'm going to do my try. I'm going to make a data input stream. So data input stream is kind of sort of similar vaguely to the scanner in that it lets us read particular types, but it lets it do it with binary data instead. And in this case, what I'm going to pass it is a new byte array input stream, and I'm going to give it data. And it's now unhappy because we haven't dealt with the IO exception. And this is not a good way to deal with exceptions during a print stack trace, but if you're going to do nothing else, do that at least. So there's 3 of them. We're going to read 3. And let's go ahead and run this one. Right, so we're able to read 1, 2, 3. So let's add a fourth one. And let's actually add this as 1, 1, 1, and 1. Actually, let's add this as 0, 0, 0, and 0. Okay. So here comes the interesting part. If I do stream.read, that's going to read 1 byte. If I do stream.read byte, that will also read a byte. Read short will read a short. A short is 2 bytes. If I read int, it will read 4 bytes. So to prove this to you, I'm going to print out read byte first. And it printed at 0. And I'm going to change this to 127. And it read it as 127. Now let's change this to read as a short. That's a heck of a lot bigger than 127, isn't it? But remember, it's taking this. Right? So back to our little flag here. If I change this to be 0, 0, 0, 0, 0, 0, 0, 0, that is 0 there. If I change this to 1, that's 1 there. If I change it to 2, that's 0 1s and 1 2. Right? This is like math, like, you know, ones, tens, hundreds, right? Well, we've got the 1s, the 2s, the 4s, the 8s, the 16s, because binary. If I passed in 3, is 1 1 and 2 2s. Right? So when we're passing in, I said 127. That's basically, and I'll probably get this wrong, and it doesn't really matter because I don't know the bit flags off the top of my head. If it has a leading one or a not, I think it would. Oh no, it would have a 0 because we're 127, right? So all of these should add up to 127. So that's what that looks like. But now you have to add a whole other batch of them before, and now this becomes the 1s over here, and then the 2s, 4s, 8, 16, 128. That means this is the 256, 512, 1024, 2048, 4096, blah, blah, blah. That's how we get up to this 32512. Okay? Kind of thing. And sorry, I'm not checking the math, so I may have the explanation slightly wrong because I'm doing it off the top of my head. My son's speaking a little loud, but generally speaking, you should get the idea. So the point is that when we read a byte, we're only reading this one. When we're reading a short, we're reading this. So if we read an int, it'll be like 4 billion-ish. 2 billion, sorry, 2 billion-ish because there's 4 billion possible values, and we're fairly high up here. And if we made it this, I'm going to take a wild guess. I didn't check this first, but I'm going to take a wild guess that we have that number there. And if I print out these might be the same. Nope, they're not the same. So I don't know what I've done wrong with my guess there, but I'm not trying to work that out. But it's going to be, it is close to that. So that is the data input stream. And what's really cool is, like I said, you can treat a byte array input stream as a file, right? So I'm taking this byte array and I'm pretending it is a file. So the data input stream just takes an input stream. It doesn't care what kind of input stream it is. In this case, it's a byte array. I could do it with a file input stream if I wanted to, just by changing this to a new file input stream. It does not matter to me at all. Writers are basically the same. If we had a writer, so you can write a character, you can write a string, you can write a character array, right? If you want to do a similar kind of thing that you did with the scanner or the data input stream, there's also a data output stream that works like a writer but for binary. If you wanted to do like a scanner, there's nothing equivalent to a scanner, but a print writer, which is just like system out print line. So print writer gives you fairly fine-grained control over what you want to write out as well. So that is the basics of file handling.